Hi folks, we're going to work on number 21 from page 210. So it's a question that involves the London Eye, which is a Ferris wheel. And let's take a look at the information that they give us. So we've got our Ferris wheel here, and they tell us that the diameter is 135 meters. But since we're going to be using the radius, I'll write that in right away. So the 135 divided by 2 is 67.5. So there's our radius. And they tell us that one revolution takes 30 minutes. Okay, so this is the information that we're given, and let's see how we can solve these problems. So problem number 1 says determine the exact angle in radians that a passenger will travel in 5 minutes. Okay, there's a couple of ways we can solve this problem. In particular, we could find the angular velocity first, but I see that they ask us about that later on. So I'm going to solve it in, I'd say a grade 9 way here. Okay, I'm going to use the fact that they tell us that it completes one revolution in 30 minutes, but I'm not interested in revolutions, I'm interested in angles. So one revolution represents 2 pi radians around the circle, since they ask us in radians. So we know that you complete 2 pi radians in 30 minutes, and now I set up a proportion, so I want to find out what angle in radians will I travel in 5 minutes. Okay, so like I said, this is not the simplest or only way to solve this problem, but this is kind of a method that will always work. Okay, so here we'll solve for x. So we've got 2 pi over 30 times 5. Okay, and 10 and 30 simplify to pi over 3. Okay. So in 5 minutes, it travels an angle of pi over 3 radians. Okay, so let's go to B. It says, how far does a passenger travel in 5 minutes? Okay, now in terms of the distance that's being traveled, that's going to be along the edge of the circle. Okay, so we're talking essentially about an arc. Okay, and we have a relationship between the arc of a circle, the radius, and the angle. Okay, and now that we know the angle that it travels in those 5 minutes, we can solve for that arc length. Okay, so our relationship is that arc length is equal to the radius times the angle in radians. Okay, and we know the radius is 67.5, and we know the angle, we just calculated that, is pi over 3. Okay, and so the arc, and that's actually a nice division there, that simplifies to 22.5 pi. And in this case here, the units are given in meters. So this is meters. Okay, and if we wanted to find an approximation here, let's do that quickly. 22.5 times pi. Okay, that's about 70.7 meters. Okay, so let's move on to C. C says, how long would it take a passenger to travel 2 radians? Okay. So again, I could solve this by finding the angular velocity directly, but I could also solve it, again, just using a proportion as we did before, okay? Because what we had here was, again, that relationship between angle and time, okay? So it travels 2 pi radians in 30 minutes, okay? And we want to know how long. Okay, so our x value is going to be a time value in the denominator. Does it take to travel 2 radians? Okay, so remember when you're setting up a proportion, the units have to match up. So radians in the numerator here and time in the denominator. So again, solve this by an easy cross multiplication. So 2 times 30 divided by 2 pi. Okay, and so here we have 30 over pi minutes. Okay, and if we want to know about how long that is, okay, now let's actually think about it. Okay, 2 radians, we know going all the way around the circle is 2 pi radians, so just over 6. So this is 2 is a little less than a third of going all the way around. So our answer probably should be a little less than 10, which it looks like it will be. So 30 divided by pi, okay, 9.5. Okay. As we expected, it should be a little less than a third of the time, so 9.5 minutes. Okay, let's move on to D. D says, what is the angular velocity of a passenger in radians per second? Okay, so again, angular velocity is a measure of angle per unit time, but the information is given to us in terms of minutes, so we'll have to do a change of units. So angular velocity, which is denoted by the letter omega. This is the lowercase omega in the Greek letter system. Okay, and what we're looking for is the angle, which we know it'll go 2 pi radians in 1 minute. Okay, sorry, in 30 minutes. Okay, so if we want to really be specific about what the units are, it's 2 pi radians in 30 minutes. So when we divide this, 2 pi over 30, we end up with pi over 15 radians in 1 minute. Okay, but what we want to do is turn this into radians per second. Okay, so we want to replace that 1 minute by 60 seconds. Okay, and so this ends up being pi over 15 times 60. Whoops, 60. And that's 6 times 15 is 90, an extra 0. So that's pi over 900 radians per second. Okay, so start with the units you're given, radians per minute, and then since you need to put into seconds, you replace that minute by 60 seconds and then reduce. All right. So let's take a look at what E is asking us. E is saying what is the angular velocity of a passenger in degrees per second. Well, I already know how many radians per second it is, so all I have to do is convert this angle in radians to an angle in degrees, and that'll give me the answer in degrees per second. Okay, so I'll do that one here. Okay, so we need to convert pi over 900 radians into degrees. So again, you can set up a proportion, or if you remember that relationship, you know that pi over 900 radians, in order to turn that into degrees, I have to just multiply that by 180 over pi. Okay, and so do some canceling out. 900, I'm pretty sure, is divisible by 180. Okay, I should know this, but let me check. And yeah, there it is. Okay, so 1 over 5 degrees, so 0.2 degrees. Okay, so the angular velocity in degrees per second would be 0.2 degrees per second. Okay, and there you have it. This question here is a really good recap of most of what we've seen in this section. Okay, that's it for now.